Hello, dear colleagues. The topic of our collective research is immersive technology for training and professional development of nuclear power plants personnel. Also, you can see for operating NPPs in Ukraine. For many decades, nuclear energy has provided a significant share of the total electricity production of Ukraine, so the stable operation of nuclear energy is a necessary condition for continued economic development of the country. In the reforming strategy of private joint stock company, National Energy Company Ukrenergo, the personal developments its key point, and as part of the implementation of a long-term staff development system, it is planned to create a corporate automated knowledge base and testing frame to develop training programs based on training centers, introduce game methods of training and assessment during 2019-2020. And by 2026, reorient training to competence development, innovation, practical improvement of technical skills. So you are able to see the aim and the structure of our research. The aim is to analyze the features and the best practices of immersive technologies used to improve the skills of NPP personnel and to promote the profession in the field of nuclear energy. As for the structure, giving examples and directions of immersive technologies application for various branches, examples and directions of immersive technologies application for NPPs, features of immersive technologies application for training of future specialists, and advanced training of NPP personnel. Application of immersive technologies for professions, popularization in the field of nuclear energy among children and youth. The slide shows the various examples of the immersive technology application for energy. For example, in Scotland, there is a VR laboratory for training staff for wind energy. This laboratory was created to improve the system of training and advanced training of personnel to work on offshore wind turbines. The laboratory focuses on virtual projections of real installations. For detailed acquaintance with installations is a digital model on which students from colleges work of maintains, diagnostics of malfunctions, and repair of the turbine can be constructed. Classes are held in the VR laboratory, which uses a special visualization system. The user, simultaneously with a three-dimensional image of the generator, sees his own hands and feet, and his physical movements are correlated with the virtual world. That is, students and staff undergoing internships can inspect the turbine using a simulation. You do not need to go to sea. In such conditions, the risks are reduced and there is an opportunity to practice skills and to train. Also, it is important to say significantly when using virtual simulators instead of training using existing equipment, where is minimized. Risk of early emergency failure of separated elements of a working complex are excluded. Thus, it is possible to reduce costs due to the absence of the need to spend money to purchase expensive components and providing tips to remove practical facilities. So, following the Fukushima Daiichi nuclear accident, the NeuroSafe 7 simulation platform was created based on the NeuroSim platform for safety analysis, operation, and engineering of nuclear reactor design. Virtual nuclear power plant, virtual 4DEC, an integrated simulation platform covering the NPP environment based on a digital reactor, informing the data provided by the digital society, consisting of digital traffic, digital meteorology, and data on processing in the Earth's crust. Based on big data, mobile internet, artificial intelligence, cloud computing, the platform, and other advanced digital technologies make it possible to simulate multi-operational operations, consider the evolution of nuclear accidents, use them to support management decisions, anticipate emergencies, and more.
The design, manufacture, assembly, operation, and decommissioning of nuclear devices are very complex processes, and VR technology can be used at all stages to save time and reduce costs. For example, foreign scientists have described a 3D simulation model of water infiltration of radioactive waste in VR. A virtual environment scenario was created for the radioactive waste infiltration model applied to the AREdu2021 repository in Brazil. Visual modeling obtained by changing the color, shade, and opacity together with the change of the height of the infiltrated liquid creates a physical perception of the probable scenario of risks. Also, it is important to use immersive technologies for modeling an NPP construction project and for a detailed presentation of various aspects of such a project. The beginning of 2020, the software and hardware complex virtual digital NPP with WWER reactor was put into commercial operation. Functionality of virtual digital NPP. So for the first, it is possible to perform calculations using a complex supercomputer, yes, and for the second, it is possible to model and test any mode of operation of power units with the VVR reactor, so it's water energetic reactor, yes, from normal operation to complex abnormal situation. In the third, it is possible to change the mode of operation and predict changes in the state of the equipment without any consequences, which in turn allows to make existing NPPs safer at all stages of the life cycle. The virtual digital NPP platform will be the main development of the modern simulators for NPP operational personnel, which will positively affect the quality of personal training and the level of safety of the plant operation itself. Virtual digital NPP is the main step toward the creation of full-fledged digital duplicates of NPP power units. Experimental operation of this complex confirmed the possibility of using the complex for emergency drills and comprehensive emergency exercises, verification of control algorithm for NPP power units, verification of emergency instructions and design decisions of the most responsible equipment. Also, the creation of the virtual power unit made it possible to conduct experiments in cyberspace, in fact are not cheap. One of the advantages of a virtual NPP is the ability to model large-scale equipment with which experiments in real conditions are in fact not really possible at all. So French companies operating in the nuclear industry have launched a reactor numérique project. This project aims to develop a digital reactor that can be used from design to decommissioning of nuclear power plants. Among the expected results of the project until 2023. And it's like two innovative products for now. The first is the digital reactor for operator training, which will reflect the physical phenomena caused by the operation of the unit and simulate various operational strategies. Operators will use a web interface instead of a full-scale simulator. So the platform will facilitate a range of research covering everything from routine operations to major accidents. Training of NPP personnel should become more efficient and the cost of staff training will be reduced. So this site actually presents the real examples of the use of the immersive technologies for staff training and students training for nuclear energy. Reliable training is important to ensure the operation of NPPs, which is the key to safe and productive activities. The cost of the slightest mistake in the energy sector can be incredibly high. In order to minimize all these risks, special attention should be paid to training.
So having a 3D model of the NPP unit, there is no need to go to the facility for training. You can train in the office. The staff will not only have the opportunity to virtually explore the facility, but also with the instructor to play different scenarios. The Nuclear Maintenance Application Center, part of the American Electric Power Research Institute, has released an interactive manual with a VR interface for working with the cherry turbine pump. So putting on the connected VR helmet and running the program, the user enters the learning environment where he is able to focus on 4 models. Yes, it's the first one is the instruction starts, an animated video showing the audio of the assembly and assembly of the turbine. Arbitrary, you can in any order to remove and replace the nose of the turbine. And the third is like a workshop. The user de-assemblies and assembly the unit with the help of prompts. The program alternatively highlights the nodes. And the fourth test, only text instructions are available. So slide provides examples of the use of immersive technologies to promote professions in the field of nuclear energy among children in youth. So here we can talk about some video games about the NPP's work. The first one is NPP Simulator. In this game, you need to monitor the devices and monitor the staff. Game Nuclear Power Plants is like actually available online. And you can play this NPP simulator on a computer with minimal power. Unpredictable situations happen in the game. One of the power units may fail and the player will have to decide different troubleshoots. So, and also the third game is a Nuclear Inc. Yes, it's like actually the second one. It's a game on the smartphone. Advanced functionality has been added to this NPP simulator, making it more difficult to operate a nuclear reactor. And it's really interesting that here you are becoming like a real engineer, famous nuclear power plant, including Chernobyl nuclear power plant and Fukushima nuclear power plant. So if to summarize everything what was mentioned about, so we can talk the economic efficiency of the technologies used for nuclear power plant, especially for immersive technologies. It's like elimination of design errors, increasing the level of industrial safety, and also increasing of the management efficiency as well. So the use of immersive technology allows us to organize the training of NPP personnel and to carry out advanced training in conditions close to the real ones, which is safer for participants and for the environment, of course, itself. And thanks to immersive technologies, the issue of nuclear energy safety have gained new importance both for NPP personnel and for the training of future specialists. Applying these technologies to acquaint children in youth with nuclear energy in an interactive form, it becomes possible to inform about the peculiarities of the functioning of the nuclear industry and prospects for the development of nuclear energy, increasing the prestige of industry professions, popularization of science and digital technologies. For now, that's all. Thank you very much for your attention.